We're given the form of the function, which is y equals kx squared, and we can take from the graph a point. In this particular case, we're given a point 1, 3 sometimes. We would be expected to identify that ourselves. We're going to plug these values in to y equals kx squared, and we're going to end up with 3 equals k times 1 squared. 3 equals k. We're asked to write the actual equation, so we're going to use that value of k and put it back in to the format that we're given. Y equals 3x squared. There's only one mark for this. For this question, we're asked to write down the equation in a different format, and this is in the completed square format. And we know that we can pick out the turning point from that. We've moved in the x direction 1 to the right, so that's going to give us x minus 1 all squared, and we've moved in the y direction 1 up, so that's going to give us plus 1. 1 mark for each of those correct. Here we're given the equation and we're asked to extract the information from it. It's in the completed square form, so we can just pick out the information that we need. The axis of symmetry is given inside the bracket here. Our axis of symmetry is going to be x equals minus 3. It's got to be in this form, you can't just write minus 3. That would be an equation. For b, we're asked for the turning point. Well, we know its x-coordinate is negative 3 because it's on the axis of symmetry. The y-coordinate is again given in the equation. It's the number at the end. In this case, it's minus 2. So the turning point would be minus 3, minus 2. And we're also asked whether it's a maximum or minimum. And that is dictated by whether the x squared term is positive or negative. A positive x squared term means a happy parabola, which means a minimum turning point, which is what we have here. Number 9, we're asked to use the graph to solve the equation. This means that we can't do any algebra. We need to just look at the graph, and we can see that the roots occur at x equals minus 2 and x equals 5. That's all we're being asked for there. In this case, we're asked to solve by factorisation, and we're being led through here. So we're solving it, so we're trying to find the roots. That means we're going to equate it to 0, and it's a trinomial. There's no common factor, so I can go straight into factorising. Numbers that will multiply to give me 6 and add to give me 7, so it's going to be 1 and 6. They're both the same, they're both positive. So x plus 1, x plus 6 equals 0. When I've got two things multiplied together and I get an answer of 0, one of them must be 0. So either x plus 1 equals 0 or x plus 6 equals 0. In this case, x would be minus 1. In this case, x would be minus 6. And our last way of solving the quadratic is by using the quadratic formula. We're going to first of all take out our values for a, b and c. A is the coefficient of x squared, which in this case is 1. B is the coefficient of x, which is 3. And c is the constant term, which is minus 1. Then we're going to use the formula, which we're not expected to remember. It is in the formula sheet. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to substitute straight in here without doing anything fancy at this point. Negative b is going to become negative 3 plus or minus. B squared is 9 minus, and here's where we need to be careful. 4ac is all together. So it's 4 times 1 times negative 1. And all of that is divided by 2. Now in the marking scheme, in an AB and also in an exam, but also just to help you ensure you get the correct result, you should always work out what's under the root first. So here we've got 9 minus negative 4. So we've got root 13. And I've got negative 3 plus root 13 over 2, or negative 3 minus root 13 over 2. And at this point, you can use your calculator. But you shouldn't be using it before now. So negative 3 plus root 13 divided by 2. It's going to give me 0.3. And I've got negative 3 minus root 3. Divided by 2, which is minus 3.3. So 2 solutions. And that's outcome 2 finished. And to complete this we need 9 out of 13.